factoring, okay? And if you look at your notes from page 3, I ended off by doing these examples. And remember how I did not actually draw the pictures? I kind of showed you a quick and easy way of doing them. And I hope that you remember the little trick for doing these is the following. Ultimately, you need to actually find two numbers that multiply to that value of c, or that constant term. And you have to also find those same two numbers that have to add to the middle term, which is -2. All right? Once you find the combination, which is sometimes hard, then you can just write it in this bracket form, and then you are done. Okay? I also showed you how to do the same thing with the pictures. And of course, I don't want you to do the pictures all the time, but I do ask you to draw a picture sometimes so you can actually understand and see the visual picture. Okay? Before we do example number 3, let's just quickly do a review question together, okay? Here's my question for you. Let's just work on this together. You don't need to write this down if you don't want to. Let me think about some numbers. X squared minus 11x. And then how about plus 30? Help me out, somebody. Don't tell me the answer. Just tell me what you would do to try to figure out this answer. What am I looking for? Yes, Jillian. What multiplies into 30? Good. And adds to -11. Good. All right, now, the question is, what times what gives you 30? And what combination of them add to -11? So, don't shout the answer yet. Tell me, somebody, what are the possible numbers that we can have in here? What are some possible combinations? Yes, Lawrence?
-6 and -5.
Okay, fine. Give me the right one right away. Okay, if you weren't as smart as Lawrence to get the right one right away, what other options could you have? You could have had like 1 and 30, right? Or like 2 and 15, right? And so on and so forth. Correct. Lawrence stole my thunder and gave me the right answer already. -6 and -5. -6 and -5. So that's great. So how do I write my final answer? X minus 6, X minus 5. And if you wanted me to draw this out for you, the idea would be, here's your 1x squared term. You have 11 of those negative rods. So I think by Lawrence's answer, there are 6 this way. 1, 2, 3, 4, 5, 6. And then 5 this way. And these should be negative, so we'll shade them all in. Okay, shade, 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 shade. And then what goes down here? A whole bunch of these little ones, and there should be 30 of them. Okay? Ladies and gentlemen, this is what we're going to do today. Back to your notes, please, and let's turn the page to page 4. Okay? These examples look a little bit more scary. What's so scary about these? Well, can you see how no longer it's just x squared? There are 3 x squareds. Yikes. Okay? Whenever you see a number in front, may I strongly suggest to you to see if you can factor out a greatest common factor. Remember we did that in chapter or section 3.1? If I gave you the numbers 3, 24, and 36, what's the greatest common factor for this? What number divides evenly to all of them? Remember this? 3, good. So 3 divided by 3 gives us 1. 24 divided by 3 gives us 8. 36 divided by 3 gives us 12. Is this the greatest common factor? Yes. Okay, now, if you didn't need to draw this L bracket and could figure out 3 on your own, that's perfectly fine. You don't need to do that. But if you really weren't too sure and you wanted to draw this L bracket, that's perfectly fine as well. So what does that mean for us? I want you to now take this original expression and let's factor out the 3. And when I factor out the 3, what is left over inside my bracket? So I had a 3x squared. I divided that by 3. What's left over? X squared. Good. Keep going. I had -24. I'm dividing that by 3. What's left over? 8. Positive or negative? Negative. Good. -8. I had positive 36. I'm dividing by 3. What's left over? Positive 12. Excellent. And if you think you're done, sorry you're not. You've got a little bit more to do. What's this equal to? You should be able to now factor that, right? You have a trinomial. That's just like what we did before. So find 2 numbers that multiply to 12, and those same 2 numbers add to -8. Okay, let's think about this. Don't shout out the answer. Think about what the combination would be. What times what gives you 12? What plus what gives you -8? Okay. I know Katrina has an answer. Let's see if we can get some more people with answers here. If you got the answer, smile at me so I know you got it. Okay, good, good. Okay, that's not a smile. Okay, all right, Katrina, help us out. What's your combination here? -6 and -2, correct. So what that means is you can now take this and let's rewrite it as 3. And instead of having that trinomial, we're going to put this into 2 brackets. That'll be x minus 6 and also x minus 2. Congratulations, you are done. Okay? Now, I'm going to try E with you. I'm not going to do the whole thing with you. I'm going to ask you for E to look at what the greatest common factor would be. You've got -7x squared plus 42x minus 63. What's the greatest common factor here that you can take out? Katrina, yeah. Okay. She suggested taking out -7. I like that. Okay, now why the -7? Why not just regular 7? Okay. Listen up here. Just watch for a sec. Okay. Just watch for a sec. If you took out just a regular 7, Shanaz, please. Okay. It's important. If you take out just the regular 7, what do you have? You have -7x squared divided by 7. What's left over? -x squared, I heard. Good. What's 42x divided by 7? That'd be 6. Good. What's -63 divided by 7? Yeah, -9. This is fine, but what's the problem with this that I don't like? And hopefully you don't like. There's a -x squared there. Hard to deal with when there's a -x squared. Okay? Ooh, don't like it. So that's why my suggestion to you is whenever you can, always try to keep the x squared term as a positive. Okay? So in order to keep this positive, what should I factor out? Not 7, but -7. Okay? So here's a little note, okay? I'm going to ask you to, when you factor out the GCF, so when factoring GCF, and please write this down, okay? You want the x squared term to be positive. It just makes life much easier, okay? So because of that, I don't want you to factor out 7. I want you, in this case, I want you to factor out not 7, but actually -7. Okay? So I'm going to ask you now, please, try this on your own. Let's see what you get inside. And then afterwards, I'm going to ask you to factor this trinomial as well. Okay? Try this one, try F, but I'm going to show you E now. Somebody help me out. -7x squared divided by -7 gives us x squared. Keep going. 42x divided by -7 gives us -6 or -6x. Good. -63 divided by -7 gives us +9. Awesome. Okay. At this point in time, yes, Oksana.
So how did it change back to positive x squared?
How did it change to positive x squared? It's because I factor out the -7. So -7 divided by -7 gives you +1, so 1x squared. Okay? Okay, ladies and gentlemen, once you get to this 3-term trinomial, once again, think about 2 numbers that multiply to 9 and add to -6. Help, help, help. 3 and 3, yes. Okay, 3 and 3. Is it really 3 and 3? Oh, yes, -3 and -3. Thank you, thank you, thank you. So this then simplifies to -7, and you can write down x minus 3 times x minus 3. And by the way, if you want to be more sophisticated, when you see 2 things that are the same, how can I write that? -7, x minus 3 squared, right? When they're the same, you can write them as a square. Awesome. Okay? All right, part F, the most tricky of them all. Let's take a look at this. It's the same idea, okay, dear friends? So don't freak out when you see a whole bunch of other letters. Ladies and gentlemen, what do you think is the greatest common factor? Katrina says -3. That's good. Is that the only thing, though? Why what? Oh, the actual value of y. Yes, yes, yes. You see how there's a y here, a y here, and a y here? Right? That means there's a y that is common to all those terms. Why don't we factor that out as well? So good. Negative 3y is the greatest common factor. Okay. What's left over now? Negative 3x squared y divided by negative 3y gives us an x squared. Good. That's what's left over. Good. 12xy divided by negative 3y gives us negative 4x. Perfect. And 96. Okay, negative 96 divided by negative 3. Use your calculator if you're not too sure. 32 plus or minus 32? Plus 32. Good. And then once again, dear friends, can you find two numbers here multiplying to 32 and those same two numbers add to negative 4? I'll let you think about that. Okay. And then if you're done, try example number 3. Okay, Maddie, what do you got? So 8 and 4 is what you said, right? Is one of them positive or one of them negative? 8 is negative. Good, because you want to have negative 8 plus 4 to give you negative 4. Awesome. And then, Mehdi, could you say that again? You had negative 3y, and what's in your brackets? Good. Nice. Ladies and gentlemen, that's the answer. Yes, Tina? No?
When you multiply negative 8 and 4, you get a negative.
Oh, interesting, dear friends. Wait a minute. Look what happened here. Negative 8 times 4 gives you negative 32. Uh-oh. Uh-oh. Oopsies. Wrong answer. Erase or cross out. So what is the right combination? What times what gives you 32 and those same things add to negative 4? Anyone have an idea? 8 and negative 4. Let's take a look then. 8 and negative 4. Let's see if that works. In this case, 8 plus negative 4 gives you positive 4. Uh-oh. And 8 times negative 4 gives you negative 32. Uh-oh again. So, Are they both negative? Okay. That means negative 8 times negative 4 is positive 32. Yes, that works. Negative 8 plus negative 4, that gives us negative 12. That doesn't work. Oh. Help. Do you want to know the answer? You really want to know? You really, really want to know? Guess what? Not possible. Trick. So if it's not possible, then what do you do as your final answer? You just leave that as is. So this actually is your final answer. You cannot factor this part. Can't be factored. So leave it as is. Trick or treat. Oh, sorry, wrong holiday. But there you go. Okay, so be careful, dear friends. Not all of these can be factored. And if you can't factor it like that, you just leave it and say it can't be factored. I'm so nasty. Would that be a nasty question on your test? Yep. Do you think I would do that to you?
Yeah.
So cruel. I'm not that way. Okay. Ladies and gentlemen, let's do one last one, and then I'll stop teaching for the rest of the year. 2011, of course, not the school year. Okay? All right. Last one here. Okay, these questions are a little bit odd. Okay, and I'm going to just show you one, and hopefully you get the idea for the other ones. Okay? It says, find all the integers k so that each trinomial can be factored. You know how I just told you some of them can't be factored? Well, I'm telling you now, you tell me what values of k. So what would that number be in front of the x so that this thing can be factored? Well, remember how we do these factoring things? We're looking for two numbers that, what? Multiply to, in this case, what do we multiply to? 8. And those same two numbers add to, in this case, k. So really what I'm asking you to do is this. Can you find all the different combinations of numbers that multiply to 8? And then use each of those combinations to figure out k. Help me out, somebody. Let's look at the different combinations for multiplying to 8. Someone help me out. What's the first one, you know? 8 and 1. Good. Both of them are positive. What else is there? 4 and 2. Good. What else is there? That's it? Negative 2 and negative 4, Suleiman says. Correct. One more. Negative 8 and negative 1. So you told me 4 different combinations, right? Now, I'm asking you what the value of k is going to be. How do I find k using these combinations? It just said add them. So let's take the first combination here. What's 8 plus 1? 9. That's one possible answer for k. Let's take the next combination. 4 and 2. Let's add them together. 6. That's another possible answer for k. How about the next one? Negative 4 plus negative 2. What's that? Negative 6. That's another possible answer for k. And finally, negative 8 plus negative 1. That gives us negative 9. The last possible answer for k. So you actually have 4 different answers for k here. That's your answer. Okay? Do you have to write all the answers? I said find all the integers. Yes. Okay? So ladies and gentlemen, I'd like you to try the next one, please, on your own. Okay? Same idea. For the next one, tell me, 2 numbers have to multiply to what number in this case? Not just 18, careful. Take the negative in front as well, negative 18. And those same 2 numbers have to then add to k. So your job is to find all the different pairs of numbers that multiply to negative 18 and then add them together to find the values of k. Good luck. Try. These answers, I saw many of you have 1 and 18, but that's no good because 1 times 18 is positive 18. I want it to be negative. What can I do to make this negative? Negative 18 or what else? Or negative 1 and 18. Good. 2 possible ones. I heard negative 9 and what else? Negative 9 and negative 9? Oh, negative 9 and what? 2. Or 9 and negative 2. Good. Anything else? 3 and negative 6 or negative 3 and positive 6. Awesome. Let's take a look together now. What's 1 plus negative 18? Negative 17. Good. What's negative 1 plus 18? That's positive 17. Awesome. Keep going. Negative 7. Keep going. Positive 7. Keep going. Good. Last one? Perfect. Mehdi, focus with me, please. Yay. If you got those 6 answers, congratulations. You're done. Okay. The last one for today. The last one for the year. How about this one here? Notice I switched the position of k. Oh, it's different now. In this case, what do I have? 2 numbers that have to multiply to k, right. And those same 2 numbers add to 2. Okay. So it's a little bit different. Let's think about this now. I heard 1 times 2. Wait a minute. We're looking for 2 numbers that add to 2 now first. So what plus what gives you 2? 1 and 1. What else? 2 and 0. What else? That's it? What do you mean infinite? Give me some more learns first. What else? Negative 4 and 2. Negative 4 and 2? Oh, 6. Okay. Keep going. What else? Okay. Lauren says, Mr. Lee, we can keep going forever, right? Because we can have a whole bunch of things that actually add up to 2. You're right. This can be forever and ever and ever. It will be the longest math question ever. Forever. Forever. So what's your answer here? If you have a whole bunch of ways, you have a lot of ways to get to. How many different possible answers do you think you have for k? I heard it. What did someone say? Infinite. There you go. There's actually an infinite number of answers. There is no set solution. You can have multiple solutions. So in this case, because this keeps on going forever and ever, you've got lots of ways to find two numbers that add to 2. So because of that, I'll say therefore k is equal to, and I'll say an infinite number of answers. You actually can't tell me them all because there's way too many for us to even count. Ladies and gentlemen, if you've got some time this winter break, and if your parents are asking you, do you have homework? You say, yes, it's this. There you go. But I did promise you, you don't need to do it if you don't want to. So if you don't want to, you can keep it until January, and we'll do that on the first day back. If you already did it, bravo to you, Suleiman. What I'd like you to do now, dear friends,